Hi everyone, my name is Frauke Baltruschat, Marketing Manager in DOW, and I will be moderating the session today. I welcome you to the DOW webinar about our new durable water repellent technology. I am seeing that people are still joining the webinar, so thank you for your patience. We will be starting in a moment. We have a great participation today. I see more than 200 people already joined. We really appreciate you choosing to attend. So welcome again to our presentation titled Protect People and the Planet with Durable Water Repellent Finishing for More Sustainable Textiles. Before we start, let me introduce our own Sean Mealy. He is a senior scientist in textiles applications and has been with DOW for 35 years. He says the launch of our breakthrough DOWSIL IE-8749 Emulsion is one of the highlights in his technical career. Sean, I am sure you can't wait to start, so the floor is yours.
Thank you, Frauke, and thank you to Fiber to Fashion for hosting this webinar today. I'm excited to be able to talk to you about our new product, DOWSIL IE-8749 Emulsion. This product provides a high-performing, fluorocarbon-free alternative for finishing textiles and improving their overall sustainability. We will go into detail on this throughout the webinar. I'd like to start by taking a short time to introduce DOW to all of you who may not know our company. DOW has been in the chemicals and material science business for over 125 years. We currently make products based on a number of foundational technologies, including acrylates, urethanes, polyolefins, cellulosics, and silicones. And our products go into almost every area of manufactured materials and products are used around the world. The packaging and specialty plastics business provides materials for not only packaging and hygiene applications, but also for durable applications such as water pipes and electrical cable insulation. The industrial intermediates and infrastructure business supplies materials for polyurethane foams, for cushioning and insulation, as well as ingredients that enable our customers to formulate their products. The third part of DOW, Performance Materials and Coatings, provides acrylic and silicone materials to a number of industries, from personal and home care to electronics to house paint. This business includes our silicones products as well as many of our activities in the textiles market. DOW is committed to increasing our sustainable solutions across all of our businesses and markets. By 2030, we will reduce overall emissions by 15% while maintaining our growth plans over 2020 baselines. Ultimately, we will be carbon neutral by 2050 in alignment with the Paris Agreement. We will significantly enable greater quantities of plastics to be collected and reused or recycled, thereby preventing their uncontrolled entry into the environment. And in addition, DOW will close the loop on our materials that go into packaging applications by making them reusable or recyclable. One area where DOW is enabling new sustainable solutions is the topic of our discussion today: fluorocarbon-free durable water repellents for textile finishing. But why is this important? First of all, many outdoor garments need some degree of water repellency. Imagine if you were unlucky enough to be the person in this upper right picture. It sure looks like their jacket is not doing a good job of keeping the water out. I guess at this point, they would be pretty miserable. To be sure, this type of garment would need to have a water repellent that has some level of durability, but that is not always the case. High-performance outerwear, such as rain jackets and winter coats, need to maintain their levels of water repellency over many wearings and many months, regardless of how often the garment is laundered. And some garments, especially summer wear and athletic wear, may be more likely to have a user's desire less water absorption with fast drying rather than strictly water repellency. So historically, DWR finishes have been based on fluorocarbons, and they've been the primary material used across the textiles industry. These products evolved to be efficient and high-performing, and they have become the standard upon which alternatives have been compared. However, the time for fluorocarbon finishes is rapidly coming to an end as consumers, non-governmental organizations, governments, and the textiles industry itself increasingly reject these materials and require acceptable alternatives. I'd like to just remind you as we move into the body of the presentation that you can submit your questions at any time during the presentation using the Q&A button that is at the bottom of the Zoom screen. By using the Q&A function rather than the chat function in Zoom, we will be better able to compile all of your questions to ensure that we get to answer as many as possible in the time allotted. So ask your questions. The greater access to information and ease of communication that we have today result in many more people knowing much more about the products that they buy and use. For textiles, the issues of ethical production, environmental stewardship, and safe ingredients are often significant considerations for consumers, right alongside the look, feel, and price of a garment. To be sure, the textiles industry is putting greater emphasis on sustainability across the world and up and down the value chain. This includes not only the operations of each company, but also the expectations of each of these companies regarding the materials they use. The DOWSIL IE-8749 emulsion addresses the need for sustainability by being fluorocarbon-free and providing excellent durability on many fabrics. The product conforms to the ZDHC MRSL version 2.0 and is compliant with Blue Sign requirements. In addition, the IE-8749 offers the excellent softness of silicone finishes while meeting the needs of high-performance DWR. So what is DOWSIL IE-8749 emulsion? As has been mentioned several times, it is a fluorocarbon-free, high-performance DWR for textiles. Built from the bottom up, containing only silicones as the active ingredients to ensure the best balance of properties and good durability. The product is effective across a wide range of fabrics, including many synthetics, as well as natural and blended fiber fabrics. Of course, I think we all realize that there are thousands of different fabrics and color combinations used across the industry in applications that need durable water repellency. So it'll be important to evaluate the product on each desired fabric and application to determine suitability in your applications. The product is sold as a high solids waterborne concentrate. However, it's easy to dilute and formulate to meet the needs of a wide range of applications. And in addition to having the outstanding softness of a silicone, the DOWSIL IE-8749 emulsion also provides a finish that is non-marking, so chalking or scratch markings will not appear, and it will not cause excessive seam slippage or separation. These pictures provide a clear visual representation of the power of DOWSIL IE-8749 emulsion when it's coated on a relatively open fabric. In this case, this is a knit polyester treated with the IE-8749 on the right. And the also almost spherical water droplets on the right indicate a surface that is effective at preventing penetration of the water, but also does not affect the appearance of the fabric. As you can see, the two fabrics look identical. As a result, fabrics that have been properly treated with 8749 will repel water while also retaining the breathability expected of these types of fabrics. During our development, we've used padding as the primary method of applying the DOWSIL IE-8749 emulsion to all of our test fabrics. And this is a common and well understood process used by many finishing mills to apply the final treatment chemicals to myriad different fabrics. The process provides excellent control of treatment levels while also ensuring that the fibers are adequately covered with a finish. This video shows the successful processing of the IE-8749 at a Scholler Technologies facility. After the fabric goes through the padder, it should be dried and cured sufficiently to ensure optimum performance and durability. This would be the case regardless of the actual process used to apply the finish. In fact, alternative finishing process could be used as well, but they would need to be tested and proven to be acceptable. Of course, once the DWR finish has been applied to a fabric, our interest turns to understanding the level of performance of the treated fabric. The most common test for water repellency is the AATCC Test Method 22 spray rating test. I'm certain that most, if not all of you, are very familiar with this classic and simple test for water repellency. So you can see in the image on the left that the water is dropping out of a funnel, out of a nozzle onto a piece of fabric that is stretched across a circular frame. And that fabric is sitting at a 45-degree angle to the water that is dropping an average of 15 centimeters in height. So it's a simple test. It's not too demanding. Everybody understands it. And you can see in this particular sample that there's no water wetting the sample or penetrating through the fabric. So the test is used the world over to ensure an appropriate level of quality of DWR finished fabrics. But there's also another test referred to as the BUNDESMANN water repellency test, which is under the ISO 9865 test standard. This test is much more discriminating for DWR performance. First off, the water is dropping 10 times farther in this test, so a height of 1.5 meters instead of 15 centimeters. Also, the samples are oriented at 15 degrees angle to the water, so it's a much flatter impact surface that the water droplets are hitting. Also, the test runs for 10 minutes, during which time 800 milliliters of water will hit each circle of fabric that's being tested. In the spray rating test, it's 250 milliliters of water over 30 seconds. Here it's 800 milliliters of water over 10 minutes on a flatter surface. In the end, this test not only will provide some measure of appearance, much like the spray rating test, but it will also provide additional data, including water absorption. So the sample is weighed before and after testing to measure just how much water each disc will absorb during the test, as well as how much water actually penetrates through the fabric. So all of the samples are mounted over cups that can be emptied and measured for amount of water that passes through or penetrates the sample. So these three test results provide a lot more information about just how well performing the samples are, and can provide measurements that will show just how well performing the treatments are in very high performance applications like winter outerwear or heavy rain jackets and similar products. So in the spray rating test, the visual rating is on a scale of 0 to 100. In the BUNDESMANN test, the visual rating is on a scale of 1 to 5, with 5 being the best and 1 the worst. So typically, the BUNDESMANN test requires a rating of 3 or higher. So fabrics with a 3 rating are good, fabrics with a 5 rating are excellent. So as I mentioned on the previous slide, the spray rating test can be less discriminating in evaluating water repellency performance across fabrics. So in this case, you can see here, across this range of synthetic fabrics treated with similar levels of DOWSIL IE-8749 emulsion, all of them display maximum DWR performance even out to 20 washes. So 0 and 20 all look the same from a spray rating test. And I want to explain too that the 2% in the legend indicates the amount of IE-8749 actives that have been applied to the fabric. So in all of our testing, we've tried to be consistent regardless of the weight and type of fabric with our amount of finish that is on all of our test samples. So in this case, 2% on weight of fabric. This translates to about 30 grams per liter for high pickup fabrics to about 100 grams per liter of the IE-8749 for low pickup fabrics. We have found that on most fabrics, this treatment level provides the best results. When tested in the ISO 9865 BUNDESMANN test, the visual ratings begin to differentiate. In this case, the two nylon fabrics begin to show slightly decreased performance as assessed by visual rating after 20 washes. In reality, this difference is small. A clear fabric face at the end of the test compared with some minor wet spots or spread water drops in the case of the 4 rating. So in either case, it's still acceptable performance. Perhaps even more discriminating though, and one that has implications for fast drying fabrics, is the water absorption or water pickup test from the result that comes from the BUNDESMANN test. Some applications require less than 20% water absorption for the finished fabric. So if we use that as our target, you can see that while there's variation across the washing and drying of the samples, in reality, all of the differences that you can see in these results are pretty small. All of them pass the 20% requirement out to 20 washes, except for the nylon spandex blend fabric, but that is very close. And remember that there's 800 milliliters of water impacting the surface of each sample over the 10-minute test duration. It's especially exciting that the polyester knit fabrics show less than 10% water absorption after 20 washes, while the uncoated knit fabrics absorb 350% of their weight in water during the same test. So a very open fabric, one that would tend to want to absorb water, is rendered quite water repellent using IE-8749. And while we'll not take the time to show the data in this webinar, studies of this product with a wash air dry protocol rather than a wash tumble dry, like we're showing here, showed very similar results. So the silicone nature of the finish does not rely on reheating to restore the water repellency functionality like some of the other finishes that are used in this application. To achieve the desired level of washing durability of the IE-8749 emulsion on fabrics, it's necessary to formulate the product with other ingredients common to DWR finishes. Most applications of IE-8749 will include a crosslinker, such as a blocked isocyanate or some other type of reactive ingredient in the finish bath. Here we show the effect of the crosslinker content in the finish in terms of the base silicone. So in this evaluation, we have treated one fabric, a woven polyester at 2% on weight of fabric of the IE-8749 actives. Then, by ratioing the crosslinker to the base, we maintain the balance of chemistry of the finish. So please note that in the legend, XL stands for crosslinker. So it's our shorthand for that term. So again, while there's some variation of water absorption results across the washing protocol, again, the differences are small. Even when using a crosslinker content that is 1/20th of the base silicone content, so that's the yellow bars that say 20:1 base to crosslinker, the performance is still quite good. Perhaps, based on these results, the most efficient level would be 10:1 IE-8749 actives to crosslinker actives. This will minimize any effects of the crosslinker on the feel of the finished fabric. Other fabrics may require more or less crosslinker depending on the final property profile required in the target application. On the other hand, the crosslinker level has a greater impact on the DWR performance of the nylon spandex blend fabric. In this chart, the data shows some degradation of water absorption performance after 10 and especially after 20 washes. So initially, all of the levels of crosslinker on these treated fabrics show excellent performance, less than 10% water absorption. But after 20 washes, the 20-to-1 ratio, or after 10 washes, the 20-to-1 ratio fabric has drifted up to above 50% water absorption. And then after 20 washes, even levels as low as 6-to-1 crosslinker level, or as high as 6-to-1 crosslinker level, so more crosslinker, are starting to show that higher level of a result. So in this case, to maintain the water repellency performance as represented by this particular test, it would be necessary to use a higher level of crosslinker, as much as 1/4 of the level of the DOWSIL IE-8749. So the results that are represented by the teal colored bars. However, this will affect some of the other properties to one degree or another. The feel of the fabric treated with a 4-to-1 ratio of IE-8749 to crosslinker will be a little stiffer, a little harsher than the lower levels of crosslinker. Again, the actual formulation required will depend on the specific targets of the applications into which the DWR treated fabrics will be used. Another variable that will affect the DWR performance is the amount of finish on the fabric. Here, we are looking at polyester knit fabric, which is quite an open fabric, such as would be used in a sweatshirt or a hoodie. In this case, we have set the ratio of base to crosslinker at 4-to-1. So we're maintaining that standard ratio. The percentages listed for each sample refer to the amount of base silicone, the DOWSIL IE-8749 emulsion, on weight of fabric from 1% up to 10%. The data show that at 1 and 2%, the water repellency, again, is represented by the water absorption, is not meeting the desired 20% maximum for this particular fabric. However, at 5% and higher, the performance is close to acceptable at 0 washes and actually improves with subsequent washing out to 20 washes to be less than 20%. So this data would suggest that somewhere between 2 and 5% may be the optimum balance of water repellency performance and amount of DWR finish. You know, the amount also will drive the cost of that finish. So typically lower is better. So in the end, we want to find the optimum balance of property and cost to provide the right kind of water repellency for each and every application. But across many applications, the DOWSIL IE-8749 will continue to perform. So the product itself, DOWSIL IE-8749 emulsion, is a high solids product averaging 70% actives. It's a silicone and water emulsion. Product is intended to be further formulated either by a chemical formulator or even at a mill into a more ready-to-use composition. This product uses non-ionic surfactants that are intended to minimize any interactions with the other ingredients that would be used in a finished bath. And it has a non-diluted basic pH. The product is available in 1 kilo sample quantities and in drum-sized commercial quantities. So we've covered some of the formulary variables in earlier slides, which I'll summarize here. Our lab investigations have indicated that 2 to 3% on weight of fabric is a good starting point for the treatment level of the DOWSIL IE-8749 emulsion. However, these levels are highly dependent on the weight and pickup rate of the fabric. So 2 to 3% OWF would be anywhere from 25 grams per liter to 125 grams per liter as supplied, depending on the fabric pickup rate used in the process. It's useful to note that some increase in finish level may serve to improve the overall performance robustness. Curing has been shown to be robust with good results at moderate conditions. Even curing for 1 minute at 150 degrees C has been shown, in some cases, to be adequate to achieve consistent performance. Of course, each finishing range will have its own drying and curing behaviors, and the consistency of results required should it dictate the actual conditions of the curing process. I'd like to point out, though, that we have not seen an impact of using a two-staged stepped temperature heating profile on the final performance of the treated fabric. But again, the actual conditions of the process will need to be determined for each finishing line. Crosslinker levels need to be determined for each application aligned to the requirements. More crosslinker will cause a stiffer hand, and too little will negatively affect durability. So balance is important. Another ingredient that we haven't mentioned yet, but is often beneficial to the finish application, is the use of a penetrant to aid in complete coverage of the fabric with a DWR finish. While we've done a limited amount of testing, we found that the use of a suitable penetrant will improve the DWR performance and overall balance of properties of the finished fabric. A slightly acidic finish bath is recommended, and the processing can be any suitable method, as we talked about at length earlier. Again, in any application, the product will need to be thoroughly tested on the finishing range before implementing into routine production. So I'd like to conclude by mentioning that if you would like more information and samples, we would invite you to visit our website at dow.com/textiles. Brochures, product descriptions, technical data sheets, and more are there. Or you can send us an email at the address for our technical customer service team corresponding to your region. Thank you so much for your attention. We'll now welcome any questions you might have. Again, please submit them using the Q&A function in Zoom found at the bottom of your screen. I'm certain there have been questions coming in throughout the talk, so I will turn to Frauke to get us started with the first question.
Thank you, Sean, for this very insightful presentation. And yes, I will come with the first question. And just a reminder again, please submit your questions at any time using the Q&A feature of the Zoom session. So let me start. Sean, what is the difference about the IE-8749 compared to current durable water repellent finishes?
So the IE-8749 emulsion has been built from the ground up with advanced silicone technologies that enhance the water repellency performance. In addition, the technology helps to significantly improve the durability of the finish and retention of the water repellency. So as a result, it's possible to have durable water repellent finish that combines both a soft feel and high performance, including good performance on many fabrics.
Thank you for the answer, Sean. The next one is, how does IE-8749 work on cotton and cotton blend fabrics? So
that's a good question. Our testing on cotton has been limited since the majority of durable water repellent applications are on synthetic fabrics. However, we have seen quite variable performance on cotton. Sometimes low spray ratings and durability, and other times acceptable performance. We did show in one set of data that the BUNDESMANN water absorption of a cotton sample was actually quite good. I'm certain that with additional testing by us and our customers, though, the picture of performance on cotton will become more clear.
Okay, that makes sense. Thank you. Next one. Is the product ZTHC or Bluesign approved?
At this time, we have not submitted for official approvals from the various oversight organizations. However, we know that our product is compliant with the technical and compositional requirements of these organizations, and we expect that the formulators that incorporate the DOWSIL IE-8749 into their products will address the actual registrations as needed.
Okay, and how about, will the IE-8749 provide stain and oil repellency?
So fabrics finished with the IE-8749 do show a reasonable degree of repellency of water-based stains. It's pretty typical of silicone materials, and we know that the finish will not pass any level of oil repellency. However, we do have a robust product that provides excellent washing durability. And so as such, the issues of degradation and staining from oils could be mitigated by washing out the contaminants.
All right, perfect. And what kind of preparation does the fabric need before applying the IE-8749?
So we've used fabrics that have been finished in water or unfinished, direct from the factories, without any additional pretreatments. But in practice, I would expect that the mills would choose to pre-treat or pre-process their fabrics in whatever way is appropriate and reliable, given the details in the processes used in the individual mills.
Okay, thank you. Now, since it is silicone-based, are there any problems regarding, for example, upcoming REACH regulations? And as an example was mentioned here, D4, D5, or D6.
Sure. This product does not contain high levels of these D4, D5, and D6 cyclic siloxanes. It is processed in such a way that the levels are far below the limits that are required by REACH. And those do align with the requirements of the ZDHC and Blue Sign organizations as well.
Well, I'm glad to hear so. Will the product meet the NFPA 1971 requirements as well?
Well, that's a good question. I do not know the details of that particular test, so I can't answer that question, but we will follow up.
Fair enough. We didn't expect you to have all the answers, but maybe this one. Could you poach labels on treated fabrics?
Could you repeat that question?
Okay, sure. Could you poach labels on treated fabrics? So I believe, can you stick labels or add them on the fabric after treatment?
Yes, that's a really good question. So the IE-8749, as I mentioned earlier, is an all silicone DWR. So as a result, its level of tape adhesion or label adhesion will be lower than many of the alternative fluorocarbon-free finishes out there. So this product has been developed for excellent durable water repellency, but the label adhesion and tape adhesion will need to be well evaluated in any particular application to ensure that it's adequate for the requirements.
Okay, good. There's a question about, I believe, how many laundering cycles does it withstand, and is there any flame resistance coming as a part of the treatment?
Sure. So the washing durability, we've tested only out to 20 washes, really because it is very time consuming to do additional testing. And as you could see from the earlier data, our results were very consistent in most instances at that point. So we would expect that we would see durability even far beyond the 20 washes on many of the fabrics. As far as fire retardancy, flame retardancy, the product is a silicone, but it is only 2% of the weight of the fabric. So the product has not been formulated to be a fire retardant treatment. I would not expect it to make the fabric any worse, but I would not expect it to have a significant effect either.
Yes, understandable. So you recommend to use 100% of the product and then it's flame retardant? Okay,
no.
Next, I joke. Next question. So What is the recommended cure process for this product? And specifically, they would like to know, do you need, can you also cure it at room temperature, or would you recommend dry or heat cure?
So this product, because we recommend that it's used along with a crosslinker such as a blocked isocyanate, really has to be heat cured. So it will provide some modest level of water repellency that would be typical of the silicone if you just applied this material and let the fabric dry at room conditions. But to be honest, in a water-based system, that's really not very efficient. And I would expect that the durability would be poor and would suffer from that approach. Whereas using a crosslinker and thermally curing the product or thermally cycling the product will result in a much better cure profile. I mean, at the base, a blocked isocyanate will have a deblocking temperature of that blocking group on that crosslinker, typically in the 120 to 130 or maybe even higher degrees C. So that's why we've found that 150 degrees C for a relatively short duration is adequate for cure. So again, it all depends on the particular processing line, but best results are going to happen if the product has a chance to be thermally cured on the substrate.
Wonderful. Now there's a question about recycling. Is it possible to incorporate this DWR on a garment into a chemical recycling process for polyester? I like that one.
Yeah, that is a good question. I would expect that, again, it depends on how much is on there. So if we go based on the 2% on weight of fabric level, I would expect that there would be little impact on that chemical recycling just because the processes used to break down the polyester would be different than what would break down all of the silicones that are involved. It is possible that you could get some contamination in the system, but that would need to be addressed in whatever separation processes are used for that. So I can't promise that it would work perfectly smoothly. At the same time, I would expect that it should be able to be processed through this type of chemical recycling.
Okay, thanks. There's repeatedly being something asked around hydrostatic heat quantification, or if hydrostatic heat is being developed. So I'm not entirely sure, but maybe you have some idea about what is meant here?
Hydrostatic
heat, will it offer hydrostatic heat is one of the questions. Next one was, yeah, similar direction.
I mean, I maybe try to guess at what the question is saying. If the question is around hydrostatic pressure resistance, much like waterproof fabric or something, a multi-layer kind of a fabric, this product has been developed to be a water repellent for the outer surface of a multi-layer garment. So in that case, it would be used in conjunction with like a Gore-Tex membrane or something like that to make a multi-layer waterproof fabric, much the same way as as is being done these days. This would just provide an alternative way to have a water repellent outer surface. You'd still need that inner layer that would provide the complete water proofness. So water repellency, waterproof, a little bit different. So if you just measure a treated fabric like we showed earlier in some of the samples using hydrostatic pressure, it would not perform all that great. It would depend a lot on the fabric, but that's not the purpose of this particular finish.
Thank you. Now, coming to the next one, is 8749 usable also as post-impregnation or only during production process via padding?
I think it could be used, but if there's another finish on the surface, like a softener finish or something, you know, alternative DWR, something like that, I think it would be difficult to completely wet that fabric and to get good treatment. If the fabric has come off the line and then goes through scouring or some other pre-treatment at the garment level, for instance, it would be possible to get this material to treat that fabric, but it would not be so efficient. I would be concerned with the amount of material that would be used. At the same time, IE-8749, to the best of our knowledge, will not really exhaust onto the fabric adequately. We haven't really tried much in that particular treatment process, but just based on the chemistry of the materials, I would not expect there to be enough attraction between the silicone and the fabric to get it appreciably onto the fabric. So I guess, so, you know, it's possible that it could be used in that manner. Right now, we don't have the data to support that process, but as I always like to say, it's worth a try, and we can see what happens.
We would like to see the outcome if you try, please. Thank you, Sean.
Sure.
Now we are looking into camping. Can we use this fabric for tent purposes, especially in resorts? So I believe bigger tents, yeah, how stable would that be and durable? Yes,
so we've not evaluated in environmental durability at this point in time. However, given that the product is all silicone, I would expect that we should see the same level of environmental resistance and durability from IE-8749 as would be seen from other types of silicone materials, even elastomer materials or other water repellent finishes. So, as I said, we've not tested it, but I would expect it to perform well. As long as the material has been well cured and cross-linked on the surface, it should provide a good water repellent finish. For a waterproof fabric application for like a permanent tent, it may be more, may be useful to have that additional layer of expanded membrane, much like a Gore-Tex.
Yeah, thank you. Now, another question, quite important. What about the durability after dry clean laundering?
Yeah, good question. We have not tested that at this point in time, although the applications that we are targeting are for garments that would be normally water laundered rather than dry cleaned. So it's a good question. We don't have the data for that at this point.
That's fair. And we had the curing question already. Next one would be, I think you had covered it in the earlier slides, but just again, maybe to emphasize, how suitable is 8749 on cotton fabrics?
So yeah, I did mention it. Our data has been much more variable on cotton than what we've seen on synthetics. So in some instances, we'll get a degrading spray rating that starts at 100 and then degrades down to maybe 75 or 80 after 20 washes, whereas the BUNDESMANN face rating, visual rating would be less than a 3. But at other times on other cottons, we have seen outstanding performance of 100 spray rating and 3s to 5s on the BUNDESMANN rating. So it depends on the fabric, and it's certainly worth evaluating in any particular application.
Thank you for highlighting again. And that's the next question is about cellulose fiber. So any idea whether it works with cellulose fiber like viscose?
Yeah, so I mean the synthetic or cellulosic fibers that are, derived from wood, I put them in the same category as the cottons in terms of their reactivity and functional chemistry on the surface. So I would expect that the performance would be similar to what we've seen on cotton, but that needs to be tested.
Right. Now, there's another question also on the curing temperature once again. So considering the curing temperature, say around 150, 160 degrees, or over the time of 3 minutes, do you expect this to damage the fabric? And then the question goes on, when the water repellent is applied and cured, is the surface matte or glossy? And if it is glossy, can the end user manipulate the solution to mattify? So you got it, or you want me to repeat?
I got it. Thank you, Frauke. That's a great question. Probably something I should have mentioned earlier. So 160 degrees C curing even for 3 minutes across the typical polyesters and nylons and cottons that we've evaluated, we've not seen any evidence that the fabric is degrading under those conditions. I think the mills would know well on their end just how stable or how sensitive any particular fabric is to the particular temperature. What I can say is that even at temperatures as low as 150, we have seen robust cure, adequate cure across all of our samples. So on that side, I would expect that whatever the fabrics can handle is going to be adequate to cure the IE-8749 formulations. As far as the end appearance of the fabric, the IE-8749 does not change the appearance of the fabric. So we've not seen any evidence that shows the fabric turning more matte or turning glossier, shinier after processing. And this is one of the positive attributes of silicones in that they don't tend to influence the final appearance of the fabric. So you don't get any Moira look or haze or shininess or matteness appearance or color shade change from this finish where that could be happening from other kinds of finishes.
I really like your answer. Thank you, Sean, once again. Now, next question is about performance booster. So could it be used as an additive to boost performance of non-fluorotextile water repellent emulsions? Any idea?
We've done some evaluations of blending the silicone and organic-based fluorocarbon-free finishes. And as would be expected, you see somewhat of a blend between the properties. I haven't seen any evidence that there's necessarily a synergistic effect. However, if a customer's application would like to see many of the benefits of a silicone system, non-marking, low seam slippage, nice feel, but maybe improve some of the tape adhesion that you would get from an organic system, it is definitely possible to blend the two types of materials. This is another reason that we've developed a product with non-ionic surfactants in mind, so that they would tend to interfere or tend to not have any interference with other ingredients. So as much as you might have ideas around what kinds of combinations to make, give it a try.
All right, lovely. We come to our second last question already, Sean. Time is flying. So this is being addressed here. Is the chemistry any different to traditional silicone water repellent products, or is it similarly based on SiH or SiOH chemistry?
So it is silicone-based, but the chemistry is maybe a little bit different than what has been used in the past and what may be expected from a DWR material. So as I mentioned in an earlier slide, we've developed this from the ground up, and the technology is based on patented ingredients, patented technology that, while still being silicone and silicone-based, is maybe a little bit different than some of those older technologies.
All right. So not revealing the secret to us. Now, let me let me come to the last question then before closing the session, and it's been great. There were a few questions about if DOW has more sustainable innovations in the textile space, and I believe we have been anticipating a bit. So, John, what can you tell us about that?
Sure. As a matter of fact, we do have several other products that we'd like to show the audience today to make you aware of what else DOW is doing in the area of sustainable materials for textiles applications. So in addition to the DOWSIL IE-8749 Emulsion, DOW Consumer Solutions also has two other new products. The DOWSIL Print 041 printing ink binder is a water-based material useful for making screen printing inks. So this product was launched last year, and it provides excellent stretch and adhesion in an easy-to-use water-based form. We will formally launch the DOWSIL AP8041 softener later this year. And this product provides the softening performance that has come to be expected of aminosilicones, while this one also being compliant with the proposed REACH substance of very high concern regulations for levels of cyclic siloxane impurities, which was referenced in one of the earlier questions. So this new product will be compliant to the limits that have been proposed. From the DOW Industrial Solutions team are textile auxiliary materials for pretreatment, bleaching, and washing, and to improve the dyeing of cellulosic fabrics. So the EcoSurf LFE can aid in minimizing foam, thereby helping to reduce the amount of water used in the bleaching process. And the final product shown in the lower right is the EcoFast Pure. That can help the customer to reach brighter hues and improved color fastness while reducing the amount of dyes needed to achieve the desired color. This is on cotton fabrics. This can help to reduce the use of water, chemicals, and energy, thereby providing a more sustainable way to make the apparel that consumers want. So back to you, Frauke.
Right, thank you again, Sean. So this is kind of the end of our session then. Unfortunately, we were not able to answer all your questions today, and the questions we could not answer will be addressed at a later stage. And again, also to the audience, I see most of you stayed until the very end, so thank you very much for joining and for your participation and questions. You will receive an email with a link to the replay of this presentation in the coming days, and I wish you a wonderful day, evening, or night, depending on where you're based. Goodbye.